recording here. And okay, let's see. All right, that looks pretty good. Okay, good morning, folks. So we are still in the midst of Module 2. And in Module 2 is where we really start to begin to look at how to do kinematics in 2 dimensions. So, so that means now you really have to, you know, be mindful of accounting for the different components of the vectors. So you can no longer just add 2 velocities just like that. You got to account for the fact that they may be pointing in different directions. Okay, so so what I was thinking I would show is this right here. Except I don't think I want to show this. Okay, hold on a second. Let's see. So if we look at homework set number 3, and then we go to our preview here. So you see here is an example where they want us to find the magnitudes of VA, that's this one, and VB, that's this one over here, given that this total magnitude here is 6.22, and given that this angle here is 24.7 degrees. Okay, so I wanted to...
Professor, did you go over this material before?
No, we haven't gone over this yet. This is the material that we are looking at in Module 3. So this is...
Where can I refer to? Is it in the book? Because when I search in the book, like I want to know if there's practice problems on there, like demonstrating problems.
Yeah, so let's see. If you go over here, let's see. So if you go to the optional problems for extra practice. So if you look in...
Can you go back? Sorry, I was looking down at my notes for a second. Can you go a step back? Sorry.
Yeah, so if you go to okay, hang on. So you go to modules, and then we're in module 3, and then you look at optional problems for extra practice. And so these are problems in the, that are directly in the book. And what I've done is I put the answers down so that you can try these on your own and then check and make sure you have the right answer. And
do you have that for other chapters, like chapter 2?
Yeah, I believe so.
Okay.
Let's see. So if you look at module 2, and yeah, optional problems for extra practice. And so you see there's chapter 2.
Where's that located in the book? Is that towards the very end? Because I like couldn't find any.
Oh, sure. So if we go to the book, which is right here, and you go to your, so if we're looking at the problems in the book, so let's see. So we're talking about chapter 2 at the moment. So that's kinematics right here. And then you go down to the problems and exercises. And so you can see, you can already see that some of these might already look familiar to you if you had looked at the, you know, the MyOpenMath. But then, for instance, if you want problem 11 in chapter 2, so that would be this guy down here, right? The student drove to the university. Okay. Now, the thing is, though, is in the textbook here, these problems at the ends of each of the chapters, right? So you see every chapter has this, right? So there's problems and exercises. You go to 3, which we're on now, problems and exercises. You know, it's always there at the end, but they don't tell you any of the answers, right? So
Oh, really? It's not like in the back, like I need to
no,
look. Oh, wow. Okay.
yeah, no, this doesn't have it. So that's why I have to put it on here for you.
Okay. Thank you.
Okay, yeah. Um, okay, so actually, but are there any other questions for me to go over before we look at this vector issue here? Okay, here, let's go back. So if we go over to the homework set 3, and then we go back to our preview. So, in the, if you go to the book here, and you look at chapter 3, let's see. Okay, so chapter 3 is all about kinematics in 2 dimensions. And so they take you through, and I have some video lectures that I posted that, you know, address each of these issues, sort of summarize the main points. So here, I'll show you where that is real quick before we get too deep into this. So I'll show you where. So what I did was, if you go to the module 3, and we talk about describing motion in 2D. And so to, you know, to introduce each section, there's a short video of me explaining what's in there and how you do, you know, how you handle the different issues there, right? And so these are pretty short. I think they're between like 5 and 10 minutes long. Okay, so you can look at those and get, you know, a bit of a flavor for it. And but what we're going to be looking at right now is, if we go back to the assignments and go back to homework set number 3. Okay, and back to our teacher preview. Okay, you don't get the teacher preview, obviously. Okay, and so we're talking about, we're showing how these 2 vectors, VA and VB, they've been placed head to tail. And so when you do that with vectors, they add together and give you a resultant. And so it's clear that what you have here is you've got V total, which is the resultant that you get when you add VA and VB. And so if you look in the book here, they tell you that there's actually a couple of different methods that you can use for adding vectors. So there's the graphical method. And in the graphical method, what you would do is you'd basically draw these, you know, exactly to scale. And then you'd get out a ruler and a protractor, and you'd actually measure the lengths of the vectors that you've drawn, and with the protractor, you'd measure the angles. Okay, so that's the graphical method. But there's also what's known as the analytical method.
Do you need a protractor?
No, you don't.
Professor, can you? Okay, okay, good.
Yeah, no, we don't need a protractor. Yeah, so for this class, yeah, you shouldn't need a protractor. But but if you wanted to use a graphical method, then you would. What we're mostly going to be using is what's called the analytical method. And so in the analytical method, you're basically just using algebra to calculate the result. So that's what we're going to try on this. So if we look at the whiteboard here, so let me stop the share. Let's take a look at the whiteboard. And so basically what we have is we have a vector VA. And so you'll see when I'm writing down vectors, I always put this, this vector symbol on top. It's a little arrow on top to indicate that it's a vector. Now in the textbook, they don't always do this because in the textbook, what they do to indicate a vector most of the time is to just use boldface type. But when you're writing, you can't really, use boldface type. And so you draw a little arrow on top to show that it's a vector. So there's my VA. And so then this can be VB. And then this can be V total. Okay. And so, so what they tell us is that this angle here I think they said it was 24.7.
Sorry, I can't read that. On the longest side, what does that say? There's A and B, and what's that one?
This is TOT, total.
Oh, okay.
Yeah, short for total. So here, if I just sneak a peek, make sure I have the right numbers. So I got, yeah, so this is TOT, total. That's A, that's B. And so, so what we have here for this angle, we have this angle here is 24.7 degrees. And we will call this angle, we will call this, we'll call it theta A for now. They call it theta, but we're going to call it theta A. Okay, and then they tell us that this angle in here is, so this angle is 26.5 degrees. Okay, and then this one is 23.0. Right, and okay, so let me maximize this again. Okay, so they've given us these angles, and so and they want us to find the magnitudes of these two vectors, VA and VB. So what you do is you need to use some geometry. So you see here, this right here is a triangle that we formed, right? So anytime you add two vectors together, and draw the resultant, you basically get a triangle, okay? And the angle over here, sorry, the angles in a triangle always have to add up to 180. So that means that this angle over here, I'll just, oh, whoops, what did I do? I kind of screwed that up a little bit. Okay. Yeah, so this angle right here is going to have to be whatever's left when you add 26.5 to 23.0 and subtract it from 180. Okay, but then by the same logic, this angle over here, so here, let me, oh shoot. Okay, I made a mistake here. I erased something I wasn't supposed to. Okay, so this is VB. Okay, and so by the same logic, this angle over here is what we call, so this angle and this angle would have to add together to give you 180, right? Because it's, you know, it's a 180-degree turn, right? Going from one side of a line to the other and staying on the same line. So that therefore means that this angle here would have to equal the sum of these two. Oh yeah, this kind of got erased. The sum of these two. So that automatically sort of means that this angle here would have to be the sum of these two. So this is 26.5 plus 23.0. So this is going to be 49.5 degrees. Okay. And so now we should have enough information to solve the problem. So if we write down the algebra to describe this situation, we say that the total vector, right, this is what they've already told us, is going to be the sum of A and B. Okay, and when you do a vector sum, remember, you're always taking the sum occurs component by component. Okay, so that means that the x component of A, right? So the horizontal component of A and the horizontal component of B have to add to give you the horizontal component of the total vector. And then same for the vertical components. So, and remember that if you have any vector, we'll just call it V, and you want the x component, that's always going to equal the magnitude of the vector times the cosine of the angle that it makes with the x-axis. And then similarly, for any arbitrary vector, the y component is always going to equal the magnitude of that same vector times the sine of the angle that it makes with the x-axis. Okay, and so the x component of vector A is simply going to be the magnitude of vector A times the cosine of 24.7 degrees. Okay, so let's go ahead and write that down. So what this implies is that the x component of vector A here, I'm just going to redraw this real quick. So the x component of vector A, so VA comma x, is going to be VA magnitude times the cosine of theta A. And so theta A is this 24.7 degrees. Okay. And then we can do the same thing for vector B. So vector B the x component of that is going to be VB times the cosine of theta B. But what is theta B? Well, theta B is this guy over here. So if I draw, right, so this is a horizontal line that I've drawn. And this angle is 49.5 degrees. And this angle here is the same as this angle here, right? Right, these are known as corresponding angles, because see, if you continue this straight line like that, and then this horizontal line and this horizontal line are parallel to each other, so then that automatically means that this angle and this one should match. So that means that the angle that B makes with the horizontal is going to be the sum of this angle here, the 49.5, and this angle here. So we would say that theta B is equal to the 49.5 plus theta A. Okay, and so now we know so now we basically have expressions for the x components of both VA and VB. So the x component of the total is going to simply be VA times the cosine of theta A plus VB times the cosine of theta B. Okay, and that's it for the x component of the total. But now, remember, the total goes like this, right? It's this one over here. So what you can also do is you can ask, what angle does the total make with the horizontal? So you've got this complete angle all the way from the horizontal axis up to V total. And you can see that this angle here is going to be the sum of this one and this one. And so we would write with that information that V total times the cosine of the theta A, actually here, you know what? Let's make a symbol, right? So this angle, we're going to call it theta total. Here, let me try to write that again so it's a bit more legible. So total, TOT, and then we say that theta total is equal to theta A plus 26.5 degrees. Okay, so we have the cosine of, yeah, so get rid of that. Okay, so we're looking at the cosine of theta total, and that is going to equal VA cosine theta A plus VB cosine theta B. Okay, so now you have, so if we look at it, So this is given. This is given as 6.22. They don't give any units, but it's just the number 6.22. Okay, theta total, we already said we know. So this angle here, we were given, that's going to be 24.7 degrees plus 26.5 degrees. Okay, so that was given. This we don't know. That's what we're being asked for. This we don't know. This here was given. This is 24.7 degrees. This we don't know. And this is given. Or this, no, this we worked out, theta b. And so theta b we said is 24.7 degrees plus 49.5 degrees. Okay, so we have one equation, but we have two unknowns. So we need another equation so that we can have two equations, two unknowns, and then we can solve. So what we just did with the horizontal components, we can do the same thing with the vertical component. So the vertical component you get by simply putting in the sine of the angle with respect to the horizontal instead of the cosine. So we would say that we have this other equation. We have V total times the cosine of theta total is equal to VA times the cosine of theta A. Oh, whoops. I meant to say sine. I meant to say sine, sorry. Okay, the sine and sine, and then plus, and then VB, sine of theta B. Okay, and so now you basically have two equations and two unknowns, and so you can solve that as a system of equations.